Alright, so next we're going to talk about hydrogen bonding and how we can tell if something hydrogen bonds, make sure that's clear, and then how we can tell what has more hydrogen bonding, which one could be stronger. In the event that you see two molecules you have to compare, like, oh, which one has stronger attractive forces, and you see two things that hydrogen bond, what do you do? So, again, it's going to be covalent molecules with alcohol functional groups, or, you know, amine functional groups that have a hydrogen on them. We won't worry about the FH, HF. That's such a, it's really working the margin. So one of these two. Now, OH is stronger than NH for H bonding. So if you see something that has an OH group versus something that's NH, this is going to take the cake. This is going to have stronger attractive forces. And then the other one is more H bonding sites. For example, more OH groups. If you have, two OH groups instead of one, you have twice as many possibilities to hydrogen bond. You're going to have more hydrogen bonding. So equals more attractive forces. Okay. So, do an example here. Let's go water versus ammonia. So what's our Lewis structure for water look like? Has that weird bent shape, remember? What's ammonia look like? Well, nitrogen is going to make 3 bonds, all the hydrogen is going to make 1, and there's a lone pair. So, this has OH groups, this has NH groups. Therefore, H2O wins, because OH is stronger than NH. Now we'll do one more example, and I'm going to bust out the line drawings for this one, so we'll have an organic molecule. And I'm going to draw 2 of them that have the same carbon backbone. And let's see, I'll make that an OH on the end there. And whoops, make that an OH. But I'm also going to add an OH over here. And so when you have an OH group on the left like that, you generally just go HO. So you got your O's and your, well, anyway, there's 2 ways to write it. Okay, so they're same carbon length though, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So the carbon chains are the same. The only difference is this one has 2 OH groups, this one has 1. That means this guy wins because it has more H bonding sites. It has more OH groups. Conversely, you could have, something with NH2 and an NH2. You could swap nitrogens for these oxygens, and it would still come out the same way, as long as it happened on all of them. That makes sense. So just whichever has more sites. If you're seeing OHs versus NHs, OHs win. If you're seeing 2 OHs versus 1, it wins. If you see 2 NHs versus 1 NH, 2 wins. So just whatever has a greater number. So that's the trend that holds through. And again, I'm gonna roll these 4 videos together at the end. I kind of had like an introductory video, then we break out in each of these attractive forces, and then I'm going to tie it all back together at the end. So there's quite a bit to digest here, but I'm trying to make it into sizable bites. But the tricky thing is, there's sort of a choose your own adventure in the middle here, and then I'll tie it all together. So just hang in there. If it's, hopefully it's starting to click, but just take it one piece at a time. All right, so next we are going to talk about dipole-dipole interactions and how to compare those.